This video will include a few examples for in class 75 since I had to be gone for class today. If you have not watched the vocabulary notes video for in class 75, please make sure you go back and do that first to fill in the top half of the page. This will apply to any angles that are outside circles. So if you see a vertex like this one that's on the exterior of the circle, what we're going to do is we're going to take that angle, we're going to follow it in, and we're going to identify the arcs that it intercepts. And there will always be two. So the first arc, the closest one, is the smallest. That would be the X in this picture. And then if we keep traveling, in this case we're a tangent, so I'm going to stay put at that point, but this one is going to follow the secant. That second example, or that second ray, intersects that second arc over there on the other side. So we have this larger pink arc, we have this smaller yellow arc that are both related to this exterior angle of 43 degrees. So kind of like yesterday, our equation is going to start with the angle. Yesterday the angle was equal to two arcs added and divided by 2. Today, since our angle moves to the outside of the circle, it's going to be two arcs that are subtracted and then divided by 2. It needs to be the larger arc first minus the smaller so that you don't get a negative number. So it's always going to be the arc that's farther away, which in this case is 149, minus the arc that's closer, which is X. We can use the same algebra steps that we used yesterday if we need to solve. So we can multiply both sides of this equation by 2 in order to get rid of that fraction. That's going to give us 86 equal to 149 minus X. And then you have some choices here. You can either add the X over and then subtract the 86, or I'm going to subtract the 149 just to show you what to be careful of if you choose that direction. 86 minus 149 is negative 63, I believe. And then there's a negative X still left here. So last but not least, we're going to need to make sure that we divide both sides by -1 to make sure that that X that we're solving for is positive like we need it to be. And then that X will turn out to be 63 degrees. So a little bit more to be careful of since we're subtracting. We want to make sure that you're careful with your negative signs. Make sure that you're not losing any of those throughout the problem. Alright, on to example B. We have another situation where there's a vertex outside the circle. So it looks like the measure of angle 1 is going to be what we're solving for this time. So our goal is to find those two arcs that are intercepted so we can subtract them and then divide by 2. So if we follow from that vertex to the circle, the small arc that we intercept first is 48. And then if we continue out, that larger arc that we intercept is going to be 132. So the order of our subtraction needs to be the large arc minus the small arc. 132 minus 48 divided by 2 is all arithmetic. So we don't need to do any solving this time. We can just subtract and divide. And we should come up with the measure of angle 1 equal to 42 degrees. 132 minus 48 is 84, and then 84 divided by 2. When we get to example C, it starts out the same way. We have an angle that's out here on the outside of the circle. So if we're thinking about the angle, it would be the measure of angle 2, because we don't know what that is going to be equal to 2 arcs subtracted and divided by 2. So if we start to travel away from that angle to where it intercepts the circle, we actually have a kind of unique situation for this one. X would be the close arc that gets intercepted, but then if I keep traveling, I never touch the circle again. So at those same two intersection points, I'm going to find my second intercepted arc, which just happens to be the rest of the circle, 232 degrees. So that's definitely going to be the larger arc, 232, because it's farther away from the angle. But I don't want to put an X in here because I already have a mystery angle. So we need to find a way to track down that X so that there can be a number in this spot so that we can find the measure of angle 2. take a second look at what that pink arc and what that yellow arc make if you put them together. Do you notice how that's an entire 360-degree circle? So our x is going to come from taking 360 and subtracting that other pink arc from it. Once we know what that x is equal to, it's going to turn out to be 128. That 128 then is going to be the second part of my subtraction problem, that smaller intercepted arc. So then again, kind of like in example B, all of this is numbers, so we're ready to go to the calculator. 232 minus 128, the top equals 104, and then 104 divided by 2 gives us an answer of 52 degrees for the measure of angle 2. Two more, and then I'm going to have you do some practice problems for the rest of class today, and we'll do the examples on the back when I'm back tomorrow. Alright, example D. We have another angle on the outside of the circle. So I'm looking at the measure of angle 1. We don't know it, but it has to be found by subtracting two arcs and dividing by 2, since it's on the outside of the circle. So if I set myself up at that vertex, I start traveling to where I intersect the circle. That's going to be a problem because it's empty, but we'll come back and we'll look at that in a second. That's our first small intercepted arc. If we keep traveling, we end up with a second intercepted arc over here, which is larger, so that's good. That's what we would expect. So it looks like the 168 is going to be the big arc, the far away one, and then I need to figure out what this yellow arc is equal to so that I can fill in the second part of that subtraction. Now the good news is I noticed there's another clue in my picture. So if I investigate that 21-degree angle, sure enough, it's connected to that yellow arc. Its vertex is on the circle, so if you think back a couple of days, when an angle is on the circle, that angle is half of that arc. So this yellow arc is going to end up being 42. 21 times 2. The angle is half the arc. So that gives me the second part of my subtraction problem to find the measure of angle 1. And one more time, it looks like just arithmetic. So 168 minus 42 divided by 2 is going to land we with 63 degrees for the measure of angle 1. Alright, last one for today, last one for this page. One more time, we have an angle on the outside of the circle. This time we know the angle, so 64 is going to be equal to 2 arcs subtracted and divided by 2. Anytime the angle's on the outside, that's what we have to do. Subtract 2 arcs, divide by 2. So if we start traveling to see what intercepted arcs are important, we get to these points of tangency and we find our close arc, and connected to those same points, kind of like in example C up above, we find that farther away arc. However, those are marked both with variables. That's going to be a problem, because if I filled those into my equation, the bigger arc would be an x, the smaller arc would be a y, and I can't really solve that because it's got two variables. So we need to think about a creative way to mark one of these in a different way. So think what we did up here. We took that big arc and we subtracted it from 360. And that's how we found our small arc. So we could do the same thing here. The small arc, which is y in this case, could be written as 360 minus that big arc. You could have also done that backwards and said that x was equal to 360 minus y. And so if I think about this as a replacement for y, or if I come back over to my equation and I think about that as a replacement for y, I'm going to put it in parentheses because there is a subtraction sign in that expression. I'm going to have to be a little bit careful when I solve, but now at least all of my variables match. So if we start to solve, I think getting rid of the fraction would be a good idea for this problem. So that 2 goes away. 2 times 64 is going to be 128. And then I need to be really careful with the top of this expression. X minus 360 minus x. Right here is a distributive problem. This is a -1, and that's going to get multiplied to both parts of that 360 minus x expression. So this equation is really going to look like 128 is equal to our original x minus 360 and then plus x. You have to be really careful with that. So if we finish that out, 128 is really equal to 360, which is negative, plus 2 x's. I'm going to go ahead and add that 360 to both sides so that I don't end up losing that negative sign. So 428 is equal to 2x, and then we can finish that up by dividing by 2. It looks like x is going to turn out to be 214. So that's half of the problem. But it's pretty easy to finish up the y. Y is going to be 360 minus 214. So the rest of that circle, we calculate that out real quickly, is going to be equal to 146 degrees. Alright, that'll be it for examples for today. Go ahead and work on your practice work. Homework 72, 73, 74, and 75 are all fair game. So try to focus on getting as many of those done. If you need to use other people in the room for help, please do. But use your time wisely so that when I come back tomorrow, we can pick up where we left off and finish up the notes.